Hello everyone, welcome back to our course which is IPE-101 Engineering Materials, and this is our next chapter which is classification of metals. Actually, metals are classified into two classes. One is ferrous metal and another one is non-ferrous metal. And I am your course instructor, Sourav Kumar Ghosh. I'm working as a lecturer at the Department of Industrial and Production Engineering at BUTEX, which is Bangladesh University of Textiles. So let's move on. So if we see the ferrous alloy or the metal alloys, those are classified into two sections. One is ferrous, another one is non-ferrous. The ferrous alloys are also classified into two types. One is steels and another one is cast irons. Steel is classified based on its alloy materials into two classes, two subclasses actually. One is low alloy steels and another one is high alloy steels. So the low alloy steels are also classified into three divisions: low carbon steel, medium carbon steel, and last one is high carbon steel. Each of them are subclassified into two sections. Low carbon steels are divided into two sections. One is plain low carbon steels and another one is high strength low alloy, which can be formed by heat treatment. Similarly, medium carbon steel is also divided into two classes. One is plain medium carbon steel, another one is heat treatable medium carbon steel, which can be treated by heat treatment so that we can get the desired properties of medium carbon alloys. The last of all is the high carbon steel. Those have two types. One is plain, another one is tool materials. Tool materials actually are very high strength materials. So in high carbon alloy, the alloy percentage mixture of any one of the metals is more than 10%. If the chromium in steel alloys is higher than 10%, then it will be called high alloy steels. Those are classified into two divisions. One is tool materials, another one is stainless steel, which is commonly used in our daily life. Let's go back to the cast irons section. They have 5 types. One is gray iron, another one is ductile iron or nodular iron, third one is white iron, then malleable iron, and finally the compacted graphite iron. We'll discuss all of these types in details in our next slides. And there is also a class called non-ferrous metal. So those are metals which don't have any iron or don't contain iron in shear percentage, or lion's share percentage of the metals are non-ferrous, or like copper or zinc or aluminum or magnesium. So those contain the lion's share of the alloy. Here comes the low carbon steel. When the percentage of carbon is less than 0.25% of whole weight of alloy, it will be called as low carbon steels. So these steels are very unresponsive to heat treatment processes because it can form martensite form. So if the martensite is formed too quickly, it cannot be treated by heat treatments. So that is why it is very unresponsive to heat treatments. Another reason is it contains very lower amount of carbon. So we cannot make a better properties or a desired properties from this kind of steels. So third point is we can strengthening low carbon steel. As we know, the if the percentage of carbon is low, then the material tends to be weaker, right? They don't have too much strength. They lacks hardness, but they are good for ductile. They shows good ductile properties. So we have to strengthen low carbon steel for our daily uses. So that's why we did some cold work to straining this type of steels. And fourth point is that these alloys are relatively soft, as I already said that these alloys are having a tendency to be ductile, not hard or brittle. So that's why this kind of material shows good toughness as well. They are very machinable, weldable, and are very least expensive to produce, as it contains very lower amount of carbon. And last point is they are generally they have a lower yield strength, which is about 275 megapascals, and tensile strength varies between 415 to 550 megapascals. And it can show ductility or elongation up to 25%, which is very high percentage actually. So let's move on the applications. Low carbon steels have some good applications in our day-to-day life. You can see in this slide different types of low carbon steels materials. First, you can see some in Bangla they call perek. Another in the top right corner there is some rods which can be used in our concrete structure or making building. And this is a structure which is used as a flyover structure. So when we use some material in the bridges or like metro rails or foot over bridge, so those materials are relatively cheap. So those materials called those are the applications of low carbon steels, and some tiffin boxes also. Then moving back to the high strength low alloy steels, which can be called HSLA steels. So these are these materials also contain very low amount of carbon, but they are very strong because they contain some other materials which can strengthen their properties or characteristics. Those materials are copper, vanadium, nickel, and molybdenum. So these four materials elements can be impurified into low carbon steel to give more strength to this kind of materials, to this kind of alloys. So these four combined concentration as high as 10% of the whole weight of the alloy. So it can make the alloy better for usage. Most may be strengthened by heat treatment after. After that, we can apply heat treatment so that the tensile strength can be improved up to 450 megapascal. So that they can be they will be ductile, formable, and machinable. The HSLA steels are more resistant to corrosion than the plain carbon steels because they contain some other elements like copper, vanadium, nickel, and molybdenum, which can resist the corrosion of these materials. We can go to the application section. So these are some applications of HSLA alloys. You can see the bridge structure or the highway structures, which may contain some HSLA materials, and huge steel structure buildings. They can also contain HSLA materials. And this is a boiler which is built using HSLA materials. So these are the applications. Remember, for metal classification, the applications are very important because we have to know which materials is applicable to which field, so that we can make or produce or manufacture those kind of materials to apply in our real life. Okay, so we have to realize the advantage and disadvantage of each of the classification of the metals, so that we can gain enough knowledge to explore ourselves in the real life applications. Okay. Now here comes the medium carbon steels. So medium carbon steels, the weight percentage of the carbon is between 0.25% to 0.60%. So if the carbon amount is between 0.25% to 0.60%, then it will be called as the medium carbon steel. These alloys may be heat treated by austenizing, quenching, and tempering to improve their mechanical properties. As you all know that we apply heat treatment to improve the machinability of a certain material to get our desired mechanical properties. So this medium carbon steel can be treated treated as heat treatment. So heat treatment can be applied to this kind of materials. And addition of chromium, nickel, and molybdenum can improve the machinability and the heat treatment ability. Okay, these heat treated alloys are stronger than the low carbon steels, but at a sacrifice of ductility and toughness. So we know that if the carbon percentage is higher than is increasing, then the whole properties, mechanical properties will be shift towards to hardness from ductility. So this type of materials will be less ductile than the low carbon steel, but it will it has a very good tensile properties, and the strength is higher, much higher than the low carbon steel. And most important thing is that it can be heat treated. We can apply the heat treatment in this kind of carbon steels. Okay. So these are some examples of medium carbon steels which are practically used. Here you can see some gear. Gear is the heart of any machineries. Okay, so we have to transfer motion from one shaft to another shaft. We have to use some gears. Okay, so these gears are fabricated using these medium carbon steels. Okay, you can see the rail line, the vehicles are also using medium carbon steels. So these are some examples of medium carbon steels in our practical life. So this is the last classification of low alloy, which is high carbon steel. If the carbon percentage is higher, which is 0.6 to 1.4% of whole body weight, then it will be called the high carbon steel. These high carbon steels are very much stronger and harder than the previous one. Actually, this is the hardest, strongest carbon steels of all. Again, the same term or same logic comes as we increase the amount of carbon, the ductility decreases, and the hardness and strength of any of a material increases. Okay. So as this has a better amount of carbon dioxide, so better amount of carbon, so it can be easily treated as heat treatment. So we can apply heat treatment and can get the desired properties. Third point is they are almost always used in hardened or tempered condition. Fourth point is oil resistance and capable of holding a shape cutting edge. Okay, that means these carbon steels are very strong, so that we can use them as a cutting tool. The tool and die steels are very good. They can be used as a tool or die. And high carbon alloys usually containing chromium, vanadium, tungsten, and molybdenum. Okay. These alloying elements combined with carbon to form very hard and oil-resistant carbide products. So, if high carbon steel alloy uses these elements as their impurity, they can be used as different field of manufacturing. In manufacturing process, the cutting tool is a very important part. So cutting tools are formed using this kind of high steel carbon, which may be called as HSS, high steel strength carbon. High steel strength carbon. Okay. So there are a lot of types of cast irons. Cast irons can be classified into five different groups. One is white carbon. White carbon usually contains less than 1% of silicon. And these structures are formed generally using perlite and cementite form, which we already discussed in the phase diagram, but you already have known about those terms, perlite and cementite. Usually they are very hard and brittle. So this is the figure. As you can see, the hard structure, and they are very brittle. That's why if the crack starts from any of the plates, it will propagate very quickly. So the ductility properties of this kind of iron is much lower. So that the toughness of this material is also lower. Heat treatment, white carbon iron above malleable iron. Okay. White carbon iron can be heat treated, and these are the malleable carbon. So malleable carbon has a heat treatment capability, which can be used at 800 to 900 degrees centigrade temperature. Graphites in rosettes, it is those black rosettes are graphites. So the carbon is trapped. So the ductility and strength can be improved. So this is the gray carbon. This is the type of gray carbon. So gray carbon has some graphite flakes. These black flakes are graphites, and they are usually very weak and brittle in tension. So they are very weak materials and stronger in compression. Actually, if we apply the tension force, it will break easily. But if we apply the compression force, it will not break easily. So it shows a good compression compressive resistance. Okay. Excellent vibration damping. That means it can damp out the vibration while it happens, and very good wire resistance properties as well. So this is the gray carbon properties. This is also one kind of cast iron. And another iron is ductile iron. From the name, we can already predict that this kind of iron will be ductile and less strong or less hard. So if we add some magnesium or cerium in the cementite or pearlite form, it can form ductile iron. This is the figure of ductile iron. Graphite as nodules, not flakes. So if we see the gray iron, the graphites are like flex shapes, but here we can see the nodulous shape of graphites. So in this figure, we can see the graphites is become concentrated in one place and become very circular shaped, not a flake shaped. So matrix often pearlite. Matrix are contain the pearlite form, and it's stronger but less ductile. But it is more ductile than gray carbon, but not as much as ductile as the low carbon steel. Okay. So these are some applications of high carbon steels. You can use them as knife, as drill bit. So drill bit is a cutting tool. We already have said that the HCS are very much capable of making some manufacturing tools like drill bit or lathe machine cutting tool or milling machine cutting tool. So those are the cutting tools of lathe machine. So these are the cutting tools of lathe machine. Okay. Hammer can be manufactured from this kind of materials. This is a hacksaw, and this is the spring. Some high strength spring is can also be used as HCS applications. So here comes the limitations of ferrous alloys. So ferrous alloys are relatively high densified. Okay, that means their weight is much higher than non-ferrous alloy. Relatively low electrical conductivities. Their electric conductivities are poor, and the corrosion rate, resistance to corrosion is also poor because of ferrous material. We already have known that the corrosion can be happened in ferrous type materials. So these ferrous alloys show very poor corrosion resistance. Okay. So these are the non-ferrous alloys. Non-ferrous alloys means they will contain less amount of iron or no amount of iron. Okay, the major portion of the alloy will be other materials, other metal elements like copper, aluminium, titanium, magnesium, and many other materials also, gold maybe. So if we come to the copper alloy can be classified into three groups: brass, bronze, and copper barium. So brass usually known as in Bangla kasha, and bronze is known as pital. So zinc is the primary impurity. So copper and zinc are mixed together to form a brass material. Okay, brass alloy. So some examples of brass are costume jewelry, coins, corrosion resistance. They show a very good corrosion resistance properties. As you can see, if we are using the coins as a taka, so that if this kind of coins cannot be hampered by the external environment, so it cannot be affected by the corrosion. So we can see we can use them for a long time without corrosion, without wear out. Okay, so brass materials are very good materials, but they are little their availability is much is not that much good. So this is a very expensive material also. So bronze is contained some tin, SN, aluminium, silicon, and nickel. So these are the primary impurities of bronze. This bronze can be used as landing gear and bushing. So in mechanical devices, bushing is a very important part. We can use bronze as bushing elements as it can reduce the weight of the bushing elements. So that the machine can run very smoothly without vibration. And copper barium is also used. Titanium alloys have the density lower, and lower than steel alloys, and they have some good high melting temperature. They can be used as space applications. Aluminium alloy, they are very low in density. Actually, they are very light in weight. Copper, magnesium, silicon, zinc can be added as impurity of aluminium alloy, and they can be used as aircraft parts and packaging, as they are very less weighted. Magnesium alloy is also very low weight, low densified alloys. They can be used as in the missiles application, aircraft application, and they can ignite easily. And some refractory materials are used in as a furnace, where we can melt the other lower temperature metals or materials. So refractory materials generally have high melting temperature, and some of the example of refractory metals are tungstenium, molybdenum, and niobium, Nb, which is niobium, and some noble metals also classified as non-ferrous alloys, gold, silver, and platinum. They are actually oxidation resistance and corrosion resistance. So these materials are very expensive, as they are found in reality in a lesser amount. So that's why those are the very expensive materials. Copper and its alloy can be used in different applications. Usually they can be used as cold working environment, and three types of copper alloys we have already discussed: brushes, bronzes, and heat treated copper alloys, beryllium copper actually. So this is the end of metal classification lecture. If you have any queries, you can contact with me. And thank you for watching this video, and hopefully you understand the classifications of metals. If you have any queries, you can comment below, and you can also contact directly with me via email or Google Classroom. So thank you very much for watching this video.